Okay. So, hello everyone. So, now we are ready with our previous year questions of hydrogen chapter. So, without any further delay, let's see the first question on our screen. Okay. So, this question is asked in 2016. The question goes like, which of the following statements about hydrogen is incorrect? Okay. So, the important thing is we are asked what is incorrect. This is important. Okay. The first option, hydrogen has 3 isotopes of which tritium is most common. Yeah, hydrogen has 3 isotopes. There is no issue in this. That is absolutely correct. So it is correct. So for the answer of this question is not this, as it is correct. Next, hydrogen never acts as cation in ionic salts. Hydrogen never acts as cation in ionic salts. Okay, we'll get back to this. Hydronium ion H3O plus exists as cation, exists freely in solution. Next option, dihydrogen. Dihydrogen does not act as a reducing agent. So this one, in this question, dihydrogen does not act as a reducing agent. So this is we are able to infer that there is some issue because, for example, let's consider CuO, like okay, oxide, okay, and let's take hydrogen. It will give us Cu plus two H2O, right? So what has happened here? Here dihydrogen can reduce oxides. Not only oxides, can also reduce chlorides, sulfides of certain metals. And it can produce free metals at ordinary temperatures. This is because, and here it is saying that dihydrogen does not act as a reducing agent. Here if we see, dihydrogen has acted here as a reducing agent. What is a reducing agent? The one which undergoes oxidation itself and reduces others. So CuO is reduced here. So definitely from +2 to it has gone to 0, right? So it is reduced. So dihydrogen is a reducing agent. This is the correct option. So we can infer that dihydrogen does not act as a reducing agent. It is a false statement and it is the answer for our question. So D must be the answer, okay? Right? Perfect. Now the next question. Okay, so answer is also given here for a verification. Now, as its melting point, at its melting point, ice is lighter than water. So ice is lighter than water at its melting point. Do you know why? We are asked why. So we have the first option. H2O molecules are closely. First of all, let me explain why it happens. Then we will see which option is right. When water usually freezes at like atmospheric pressure, there is normal hexagon form. At atmospheric pressure, there is normal hexagon form. And each oxygen atom, it is surrounded with 4 hydrogen atoms. Okay. And 2 are bound by covalent and 2 by weak hydrogen. And since these hydrogen bonds we know that these are longer than covalent bonds. Hydrogen bonds are longer than covalent bonds. So the molecules of water, like they are closely packed of, they are not as these are the hydrogen bonds are longer than covalent, the molecules of water, they are not closely packed for crystal structure. So there are small hollow spaces. So this is what decreases the density of ice. So eventually, as the hydrogen bonds are longer than covalent bonds, the molecules of water are not closely packed in crystal structure. So there is existence of hollow space in the crystal structure. So this will decrease as there are hollow spaces. This will decrease the density of ice eventually, right? So this is a phenomenon we understood. Now let's see which option is right. It is here written: H2 molecules are closely packed in solid state. So this is not the reason for why ice is lighter. Ice crystals have hollow hexagonal arrangements of H2O. Yeah, this is right. Still, we will see the two options. On melting of ice, the H2O molecule shrinks in size. Ice forms most heavy water on first melting. Okay, so B is the most accurate answer which we get. Okay. So next question. We have understood that the answer to this question is B. They have hollow hexagonal arrangements, and this is the reason the ice is lighter than water. Okay, clear? Here the answer is also given. Okay, so B is the right answer. We have understood. Now, role of hydrogen peroxide. Hydrogen peroxide is H2O2 in the above reactions. So let's first thing is you are asked if it is oxidizing or reducing. So let's write the reaction first. H2O2 plus O3 here. If we see the O3, we have given O3 and H2O is given. So if we interpret here, the reaction which we will be getting is, here it is 0, right? And here also, here it is -2. So it has been reduced. And so here it is -1 and here 0. This is what oxidation number we are calculating this. So O3 to H2O, it is reduction is going on. The first thing is, so the hydrogen, it is reducing in the first one. So it is oxidizing agent. And in second equation, in second what is happening is H2O2 plus Ag2O gives 2Ag H2O plus O2. Right? Now what is happening in this particular reaction? Here it is -1. Okay. But H2O, it is -2 and O2 is in zero oxidation state. So H2O2, there is also again reduction here from for example, Ag is in zero oxidation state and Ag2O So 2x minus 2. So is equal to 0. So x is equal to 1. So 1 to 0. It is again reduction going on. So basically H2O2 is acting as an reducing agent, and it itself is undergoing it is acting as a reducing agent because it is reducing other elements, right? So the answer is C should be our answer. Okay, so let's check. Yeah, C is the answer. Okay, here on this occasion, we got this question. I would like to make you go through one important thing which we were supposed to know in this question, some reaction of oxygen H2O2, which is important for us to understand. Okay, so for example, H2O2. So H2O2 is there, and it is acting as a reducing agent, oxidizing agent, and reducing agent. It can act as both. So in acidic medium, the H2O2 is converted to H2O. In the basic medium, the H2O2 is converted to OH minus. Clear? This you need to remember basically. As a reducing agent in acidic medium, H2O2 is converted to O2. In basic medium, H2O2 is converted to O2 plus H2O. Okay, now? So this is the important thing which you need to remember. Any question is asked, you can solve it using this, right? Next question. Let's move to the next question. Okay. We are given when H2O2 is oxidized. So here we have seen H2O2 is oxidized. What do we get when H2O2 is oxidized? So in oxidized method, it is acting as a reducing agent. So in reducing agent, H2O2 will give us O2 for sure. So here B should be the answer. Okay, so B is the answer to this question, right? Simple. When it is oxidized, what happens? By seeing this, we can understand, right? Next question. So hydrogen chapter is all about how many times you have revised it. Okay, so many different kinds of questions can be asked in different ways, but the core concept would remain the same. Okay, so volume strength of 1.5 N is normality, okay, H2O. Volume strength, we have two formulas, okay? Volume strength is equal to 11.2 of molecularity, or volume strength is equal to 5.6 into normality. So here we are given normality. So 1.5 into 5.6, what would it be? It will be 8.4. So 8.4 is the answer. As simple as that. It's a direct formula. These are two formulas. Remember these formulas. Any sort of question can be asked from these formulas. Okay. Okay, we got the answer right. 8.4. Okay. So next question. So the next question is, question number 6 is, in bond angle in H2O2. So here we have H2O2, right? So think for a moment that how can this bond be formed? Like H2O2, we know H2 hydrogen, H2O bond we know. But how can H2O2 bond be formed? Can you think? Let me tell. So it is an important thing. H2O2, it is, first of all, it is a non-planar structure, okay? And it is open book. The structure is like open book. Open book in the sense, here oxygen, the bond between O and H is 94.8. Okay. And maybe the another sometime bond angle is asked this time. Bond length may be asked. The bond length is, here it is 95 pm picometers, and here 147.5 pm. Okay. So the nearest option which we have is 97. That is D option should be right. So it's open book structure. Remember this. Okay. The next question we have. It is asked. Excuse me. In the reaction of H2O2, the reaction of H2O2 with sulfur. So H2O2 we have. Let's take H2S. How can we? So let's see what will happen. We'll get H, which has S plus 2H2O, right? We will get this. So here H2O2. There is also what is happening here in this particular question. H2S is oxidized to sulfur. Okay, H2S, there is oxidation going on, -2 to 0. And H2O2, there is reduction if you see. Right? So eventually, the redox reaction is happening here. So addition not happening, oxidation is not happening, reduction is also happening, oxidation is also happening. So the answer is the redox reaction. So this question shows how important it is to solve a question fully. We saw that H2O2, H2S is going to S and there is oxidation. And we choose B, then that's mere foolishness, right? So we need to solve it fully. We need to see what is H2O2 also undergoing. Then we can choose option D. Here it is given. Which one of the following pairs of substances on reaction will not evolve H2 gas? Will not evolve H2 gas. So first of all, it is given iron plus H2SO4. So let's write its reaction. Iron plus H2SO4. What is it giving us? It will give us FeSO4 plus H2. And iron plus steam. Steam is nothing but water. It will also give us Fe3O4 plus H2. And copper and HCl. Cu plus HCl. But in this, the thing is there is no reaction possible because in electrochemical series, this Cu is below hydrogen, so it cannot produce hydrogen, right? So there is no reaction here. So C should be the answer. C is the answer. But still, let us see the next option: sodium Na plus ethyl alcohol. Excuse me. So sodium and ethyl alcohol, it will give us C2H5ONa plus H2. Yeah, there is evolution of H2 gas. Excuse me. So C should be the answer for sure. Okay. C is the answer. Okay, we are done with this. Now moving to the next question. The answer is C. Excuse me. Extremely excuse me. So next question is when a substance reacts with water. Okay, let's get back. When a substance reacts with water, it produces a combustible gas B. Okay, nice. When a substance, so when a substance reacts, A reacts with, let's take A first. It reacts with water. It produces a combustible gas B. And a solution of C. In water. When another substance D reacts with solution of C, it produces same gas B on warming. But D can produce gas. D can produce gas B on reaction with dilute sulfuric acid. Okay, very nice. A imparts a deep golden yellow. So with this, we must be able to understand one thing. A deep golden yellow. So if we have read S block, if we have read or gone through S block, there the alkaline metals have colors, right? So here the knowledge of colors of alkaline is used. Why? Because it is saying that A imparts golden yellow color to a smokeless flame of a Bunsen burner. So we know colors. Do we know colors? Just a second. So we know the fact that Na can produce yellow color, right? And other elements, other alkaline metals like Li produces crimson red, Na produces yellow, Rb produces red violet, Be produces no color. Like these are the colors which are produced, right? And so by this we can understand that Na should be produced. Okay, Na should be the important thing here. So first option seems very correct, right? Na is the one which will produce. So let's check if that is true or not. So if we consider Na plus H2O, what will happen? Na plus H2O will give us NaOH plus H2. Let us write the reactions, whatever are given. Okay. Na plus H2O. It will give us NaOH, that is liquid, plus H2 gas. Okay, fine. So now this H2, when another substance D reacts with this solution of C, so NaOH is reacting with a substance D. Again, it is producing H2 gas. H2 gas. So NaOH plus something will give us H2 gas. And so what is that something? Here by options we can say that NaOH plus NaOH plus Zn should give us this, because in options if we want to match we will get in this way. So NaOH plus Zn will give us H2 gas plus Na Na2 ZnO2. Right? We are done with this. Till here we are clear. Now the next statement is but D can produce gas beyond reaction with dilute sulfuric acid. So what is our D here? Zn. Zn plus dilute sulfuric acid. It is said that it can give us ZnSO4 plus H2. So everything is satisfied, right? Wonderfully. So A is the right answer. The only thing which we could understand from the last statement, which is very important, is deep golden yellow that can happen only to Na. So this was the understanding which we required, and rest everything we were just checking. Okay. So yeah, we are done with this question. The question which appeared so huge and very complex is solved in this way. So this is the way the questions are asked in hydrogen. The next question is the hydride ion H minus is a stronger base than the hydroxide ion. Oh, H minus. Okay. Which one of the following reactions will occur if sodium hydride is dissolved in water? So what is said here? It is said NaH is dissolved in water. Also, in hydrogen chapter, we have different type of reactions. There are approximately 30 sort of reactions, not very complex reactions, but very simple reactions. So the best thing you can do is once you need to make a note of all these reactions, and once you need to write it. And once you write it, it will be full-fledgedly occupied in your mind. So that will help you. Okay. So now the question is asked, when NaH this is sodium hydride, it is reacted, then what is the happening? So here H minus is a stronger base. So H minus base 1 plus acid, if we say H2O, it should evolve as OH minus and H2. That's H minus as the base. It accepts one proton from H plus and becomes H plus. H minus, OH minus, H2. Okay, it will happen from H2 and this will form H2. So the option which is right is B, as it is seeming the reaction we wrote and the reaction it is observed here is C. Sorry, it is B. H minus plus H2 will give us OH minus plus H2. Okay, this is the way we were supposed to interpret this. Next question we go. The ionization of hydrogen atom would give rise to ionization. What do you mean by ionization? Adding of electron, right? We have read about ionization even in atomic structure. So, what do you interpret by ionization? It is nothing but we are adding the molecule will gain or lose electrons, and there will be some charge. Not necessarily always gaining, but yeah, there will be some charge, that is ionization. So here we have the ionization of hydrogen atom would give rise to. So let's first ionize the hydrogen atom. So it is giving us a proton. Ionization of hydrogen is giving us a proton. So do we have proton in our options? And do you know what is the ionization energy of this? The first hydrogen ionization energy is 13.6. The subsequently 3.4, 8.0.8. You know this, right? In atomic structure, we have read first 1, 2, 3, 4. 4 ionization states you must be able to remember. Okay. So the answer is hydrogen. When we add electron, we'll get proton. The number of hydrogen bonds in so and so. So here we can see 5H2, but when we see structure, it's a structural sort of question. There is only and only one and only hydrogen bond. So only that hydrogen bond. So the answer is 1. 1. So answer is C. Because also only one water molecule is associated with the molecule via hydrogen bond. Okay. So the answer is C. So this is a structure based question. You should know structure for this. So these are what do we say? C and answers sort of questions. We usually divide questions in three types, right? A, B, C. The one which you can answer just by seeing is A. The one which you can answer by coming back again, which will take a bit time. The questions that come under these are B, and the questions which need a bit of brainstorming are C. So whatever questions we are solving till now, most of them are coming under category A. Okay, and this is how the questions will be asked in the exam. The method used to remove temporary hardness of water. So temporary hardness of water. So in hydrogen chapter, there is an important concept of hard water, the temporary and permanent hardness, right? So we remove temporary hardness by Clark's method. Okay. Why does temporary hardness occur? Do you know? Because of Ca and Mg. And with Clark's methods, we add CaOH taken twice excessively in artificial hardness, and that will be removed. So temporary hardness is removed through Clark's method. The answer is given B. And all permanent the permanent hardness is due to sulfates of chlorine and lithium and the water. And to soften water, the water softeners are washing soda, permitted Kalgan method, ion exchange. So these resins, so these are for hard water, and only Clark's method is used for temporary. So B is the answer for this. Okay, right? We are clear. We are going good. The next question is: some statements about heavy water are given. Okay, so heavy water is used as moderator. Is used as moderator, and in nuclear reactors. Okay. The next statement is heavy water is more associated than ordinary water. Okay. The next is heavy water is more effective solvent. Okay, it's a nice and observable term, effective solvent. So more effective solvent than ordinary water. So which are correct? For this, what you need to know is we need to know properties of heavy water. Okay. You need to remember properties of heavy water. You can refer NCERT for this. So let's go with the first thing. You know formula D2O, we represent heavy water with D2O, right? And it appears in pale blue color. And so here it is given that it is used as a moderator. Heavy water, yeah, it is used as a moderator in nuclear reactors. That's the most important property of heavy water. So A is right. And heavy water is associated with ordinary water. So in first of all, let's discuss A. It is used to slow down the speed of neutrons in and used as moderators in nuclear reactors. Okay. Also, a few properties are like boiling point of heavy water is more than ordinary water. So we can say it is more associated, right? The elements are more associated, the atoms are more associated. So that's the reason it is hard to vaporize it, boil it. So yeah, that is right. B is right. And heavy water is more effective solvent than ordinary. Here there is some issue because the dielectric constant through which we talk about the efficiency of solvent, the dielectric, the sorry, So the dielectric constant, the dielectric constant is what is more associated with the effective solvency. So, but the dielectric constant of heavy water is slightly less compared to ordinary water. Since ordinary water is more effective solvent than heavy water. So basically A and B are right, right? Okay, understood? So answer is B. Okay, answer is B given. Next question. Which of the following groups of ions makes the water hard? So hardness of water is the most important thing in the whole concept of hydrogen chapter. So there are two types of hardnesses, right? Temporary and permanent. So bicarbonates of temporary hardness is due to bicarbonates of calcium and magnesium, and permanent hardness is due to sulfates and chlorides. We discussed it just now. So magnesium and chloride, this seems right, right? So temporary hardness is due to bicarbonates of calcium and magnesium, and permanent hardness is due to sulfates or chlorides of both calcium and magnesium. So sulfates are the reason here, bicarbonates are the reason there. So magnesium and sulfates of Cl and Ca are also reason for permanent. So we can say that magnesium and chloride are the reasons, okay? Yeah. The next question is, the dielectric constant of H2O is 80. Okay. The electrostatic force of attraction between Na plus and Cl minus. Na plus, Cl minus. So basically what is the dielectric constant is also called as relative permittivity. So this factor is used to determine electric field between charges is decreased relative to vacuum, right? When there is vacuum, the electric charge is decreased. Or air, we can say in vacuum, the electric charge is decreased. So that is what we factorize here. So in liquid state, the H2 molecules are together, right? By intermolecular H bonds. So when the water is freezing at atmospheric pressure, so here we are given that the dielectric constant of H2 is 80. So electrostatic force of attraction between Na and Na plus will be. So basically it will be reduced. And it will be reduced by the dielectric constant. So 1/18th in water will be the air. So the dielectric constant as it is given, we can figure out that it will be reduced. So we can choose option B. So we know the formula, right? K is equal to E by E medium by E. So this is what we can say, that 1/18th it will be reduced. So the option, which option seems right? The option B seems right. And here why we have reduced by 1/18, because as NaCl is a polar compound and like dissolves, the forces of attraction between Na and Cl will be reduced by 1/80th. I mean 1 by dielectric constant. So this was the question. Next question we see. So this is the answer given here also. Here it is important thing again. We are asking, this is a question from hardness again. So here Kalgan, the formula of Kalgan is asked. So we should know that, we should remember this point basically, that the Kalgan method which we use, in that the formula of Kalgan is Na. It is nothing but Kalgan is a complex of metaphosphoric acid. So it is sodium hexametaphosphate. Sodium hexametaphosphate. So 2,4,6. So here we should get Na2, Na4, PO3 taken 6. Okay. So this is Kalgan. It is sodium hexametaphosphate. When it is reacted with CaSO4 and MgSO4, the sulfates, so then we will get Na2SO4 out. And the inside Na is replaced by the Ca and Mg respectively. So this is what we get. Okay. So 2, 4, 6. It is important to know 2, 4, 3 to the 6. So some way or other way remember this formula of Kalgan. Okay, next. So these were few questions which we discussed today. These are the important questions we discussed. So the most important thing about hydrogen chapter is we should know the isotopes. Let's talk what all we have spoke about. And what are the important things of hydrogen chapter? So we need to know about isotopes. We need to know reactivity of them, bond energy, their effect. And we need to know the properties of hydrogen. In that, how does it react with the different metals? AgCl, how does it react? CuO, how does it react? And methods of preparation of hydrogen, we need to know. There is one process of Lane's process that we need to know. And then we need to understand that electrolysis of water, even 1 minute, electrolysis of water, this is also one of the important. And डिंगम को दे देना वो जरा हाँ bye. So we need to understand industrial preparation and industrial preparation of hydrogen. Okay, there are few physical properties of hydrogen and chemical properties of hydrogen. The reducing property of hydrogen. This question is asked, right? The reducing, regarding the reducing property of hydrogen. And then we need to understand about hydrides. The thermal stability, how does it decrease as the size of cation? That we need to understand. There are different 3 types of hydrides that you need to understand. And the structure of H2O2, open book structure, the bond angle which spoke about, preparing of H2O2 by Merckx. These are few important things in hydrogen chapter. The strength of H2O2, the percentage strength, volume strength. Okay, we have solved this question. And chemical properties and how does H2O2 behave as an oxidizing agent and reducing agent, right? And when we come to bleaching action, we need to understand hard water, soft water, why hard water, temporary hardness and permanent hardness. And how can we remove it? The methods, the different methods. The in ion exchange resins, we need to understand cation and anion bed. So these are few things basically which we talk about in the chapter of hydrogen. So these are important aspects we talk about in chapter hydrogen. I have summarized it once as we have discussed it. Still, you need to revise it, go through it. It's a very scoring subject, if I say. It's a very scoring subject for real. For scoring chapter for real. So, hope this chapter will let you solve and gain confidence in the exam. So, yeah. That's all from my side. Hope this chapter helped you revise it again and again. We have spoke various concepts in this. So yeah, that's all from my side. Have a very effective, productive study. Enjoy the process, and everything will happen accordingly. So yeah, thank you from my side.